PLA, PLA is just because it's PLA, it's bio-based. Like there is no alternate. It is bio-based just by, it's not like it's on a slightly different level. So when it's PLA, you don't even question whether it's bio-based or compostable because it is PLA because it is that. So it's a very different thing, and it's not really.
Hello and welcome tonight to our double premiere of Plastic Climate Future, because it's the first time that we are partnering with another organization, and this one is Circularise, and we're just kicking off our special series on sustainable polymer technologies, and that's why I have Maspa Sabur with me. And the other premiere is that we're trying to do a first video podcast. So you also see our faces while we're talking. If this will be a good idea, we will judge afterwards. But yeah, let me first say hello to Mespa, my co-host today, the co-founder of Circularise, and then also introduced our very special guest that we have tonight. Hello, Mespa. Nice to have you
Hi,
here.
Matt. Well, pleasure being here. Thanks so much for allowing me to co-host this. Looking forward to it. And also, the video is a different experience, I would say, but I'm starting to like it. So looking forward to this and watching and judging ourselves afterwards.
Yeah, we already discussed before that the light is the most important, so we were playing already for half an hour with our lights. But I think the shining light tonight is our guest, because we are honored today to have Thomas, the CEO from Total Corbion, with us to talk today with us about the challenges and the future of bio-based polymer technologies. So in that sense, hello, Thomas.
Good evening or good afternoon to you guys. Yeah, my name is Thomas Philipon. Indeed, I'm the CEO of Total Energies Corbion. We just changed our name, so we thought it was not complicated enough, so we have extended it to be named after our parent company called Total Energies and the other one called Corbion. So indeed, it's Total Energies Corbion. But we'll talk more about that.
Perfect. And where are you tuning in from, Thomas?
I'm calling out of Geneva, where I have my home, but the company is headquartered in the Netherlands, in a small village called Gorkum.
Nice.
So you have to help me in the pronunciation. I'm not native. I've been told it's
Gorkum.
But we have to pronounce it. Yeah, Gorkum.
Yeah, it's a hard one. It's Gorkum.
It is this.
Yeah, that's one. This was one of the reasons why I chose to do the podcast series with Mespa to have some
Dutch
help
pronunciation.
On the Dutch names.
That's my role tonight.
Yeah, thanks a lot for your time, Thomas, and for giving us the chance to dive into not only the activities of Total Energies Corbion, but also giving some insights and outlook on the future of bio-based polymers. Before we start, we have actually, as a Plastic Climate Future, also big interest to get to know the person who is behind the innovations and companies that we highlight in our podcast. So maybe you can tell us a bit more about the person, Thomas, and how you got to the job or position that you have today, and maybe about some interesting pivots during your career that led you to sustainable polymers.
Sounds good. I did reflect a bit on who I am and why I'm here, and I think it's good when you get into 50 years of age to have a good idea of why you're here. No, but joke apart, I'm really, as you can understand from my accent, I'm from France. I've been always studying and being basically educated in France. I think I'm pretty normal French engineer from that standpoint, which is not normal with me, is that I start traveling around. So very early in my careers, I went abroad. So I lived in 3 continents, in 5 different countries, and I never worked in France. So that's a bit the fun fact about myself. But this is really above the point. I was trying to think more about why I'm in sustainability, and that is a moment that I could actually trace back, which was very specific. So I'm also a proud father of 2 children. One of them is a boy, he's 17, and the girl is about 14 years old. But at one point, when the boy was about 10 years old, I remember vividly telling him how to do different things. And there is one moment where I was very proud of, is we went together to the recycling center. And at that moment, I was not only helping him, because he was too small to get into this hole and just drop the bottle. And then I realized, you know what, I think it's the right thing to do. So that was very vivid with me, and I kept that with me. At the time, I was working for DuPont, a very well-known company when it comes to specialty polymer or specialty resins in the famous plastic world. Already there, I was known as a plastic guy with a green mind. So I always inherited those plastics that nobody really knew how to position. It's partially bio-based. It can be recycled. What can you do about it? And I ended up having all these little projects or businesses with me during my career, the more I was going up. So at one point, I had that pleasure and that opportunity to drop a ship between brackets from very good plastic school and go to this initiative, which is really a joint venture between 2 giants. One is called Total Energy, the other one is called Corbion. So one is really doing the best they can in order to ferment bio-based material, and the other one is doing what they can and the best they can in order to be able to put solution on the market based on polymers. So now I'm leading this initiative, which is really taking the bio-based material and turning it into a solution. So I'm basically here not only to do the right thing, like I was doing with Antoine, but I'm also here to share back what I learned, how we can make a business out of bringing solution to a market. And I'm pretty proud to do that in a sustainable way now.
Cool. This is kind of like honey in my ears. I don't know if you would say that, but it's music. Yeah, it's music in my ears because I think this connects all of us, including also MESPA and our passion from Plastic Climate Future about creating awareness and bringing out this passion to our listeners and our audience.
Yeah, it's great to hear that you've been known as the green plastic guy. So this has been throughout your DNA, throughout your career. It's not something that just is now a hot topic, as I hear. Maybe good to kind of start off also on talking a little bit about PLA. What is PLA? What is it special about? I guess not everybody knows about it. And how would you explain it to your kids? And how would you explain it to a little bit more of an expert?
Sure thing, indeed. That's 3 different letters, and then I said, okay, I'm going to explain it to you. It's called polylactic acid, and then the face changes, right? It's not very much helping, right? So let's put it in a different angle. I mean, the PLA, the polylactic acid, is what we all call a plastic. So if you see it, you touch it, it would feel and seem very similar to a plastic, but there are very much differences to it. First and foremost, it's coming from sugarcane. So basically, what we use as very much as a material to start with is the sugarcane. You take the sugar from the sugarcane and you ferment it. Fermentation is basically you leave it somewhere, a bit of heat, a bit of humidity, and you turn into something else called lactic acid. And this is really the ingredient that I would use in order to turn it into a plastic. So I go from, if you want, basically a field with sugarcane and with several operations, then you end up with something which looks like a pellet, which is a plastic pellet. And this is what we sell in order to make the items that we all touch every day: a bottle, a film, some thermoform trays, which is really the trays where you have all your vegetable in it, or where you have basically some of the fruits. So this could be very under multiform shapes. And this is really what is super for us, because today what we have is a new kid on the block, a plastic which looks like plastic but is not plastic, which is done in a sustainable way. And we are basically very busy trying to find a place where we could replace basically petrochemical based plastic, which are coming from fossil energies that you cannot get in a renewable manner, and replace that with something that you can grow back. So that's the very first and foremost difference, right? You are using what we call renewable carbon, something that you can replant if you want. So that's one first and foremost difference. That's the start of life, we call it. The other big difference with this type of plastic is you can give some very positive end of life to that plastic. So depending on the application, sometimes if I take an example, if you have a tea bags, there is a lot of tea in there, and there is basically a bit of a film of plastic around it, actually a non-woven solution. And this you could use a PLA, and then you don't have to recycle or to burn basically this plastic part. This type of plastic would be what we call compostable. So think about it that way. You take not only the tea bag, but actually the packaging of the tea bag, and you put it in your compost, and you would just not damage your earth. It would actually enrich it, and you would go away. So that's one of the end of life of this special plastic. But we can also have access to recycling streams, and the PLA is easy to recycle, and I can turn it also in a different type of use after the recycling. So it's basically completely bio-based, coming from the renewable resource. It is biodegradable or compostable, as I said, for the little tea bags. But I can also recycle bottles made out of PLA as a normal plastic to recycle. So it has also this type of properties. So that's fine difference. When you are in the industry, it's huge. When you are from the outside, you need to understand that we can do basically a lot of different plastic items now with bioplastics and with the PLA in particular.
That is so interesting, because PLA is not like in traditional, like let's say you talk about PP, you can have it bio-based or you can have it based on fossil fuels. But in case of PLA is just because it's PLA, it's bio-based. Like there is no alternate. Like, it is bio-based just by, it's not like it's on a slightly different level. So when it's PLA, you don't even question whether it's bio-based or compostable, because it is PLA because it is that. So it's a very different thing, and it's not really like with more traditional plastics that's more common to people, like polyesters, etc. It's not where does this polyester come from? Is it bio or fossil? In case of PLA, if it's PLA, which is quite interesting, and it's a different proposition, really. Is there any negative sides on PLA compared to traditional plastic? Is there some things that they can do, or is it just equally in terms of the chemistry? It's just like a different source.
Yeah, no, that's a very good questions, and part of our motto in our company is definitely transparency. I think we come back to that, and but we want to be able to educate the world, right? And we are very much fact-based. You can go and check every single thing we post, because we want to be part of that discussion in a positive way. So it would be really wrong for me to tell you that PLA is the solution for everything. Which would be equally wrong is to say, okay, you can have only polyester or only polypropylene or only polyethylene. I mean, it does not work like this, right? You need to basically adapt a solution to a certain situations. So with PLA, what is possible today are the main, I would say, low-level application where we could basically have a proposition. So I'm talking about the shopping bags, that you can find. I told you already about some of the thermoform trays. These days they don't really need too much performance, as we say in the industry. So they are relatively easy and they are good to start with. So that's really where we started. But no, the more we know about PLA, and that is really fun for me and being in the plastic industry, is we find more and more applications for PLA. We change slightly the formulation, always being bio-based, having basically the same footprint, but you can play on the viscosity of the polymer, you can play a bit on the formulation with other bioplastics. So we're getting to different type of application. And that is really the challenge, is to say, okay, how can we replace more and more of these petrochemical-based resins with PLA? So I think the shortcoming, if I want to put it in a positive manner, is the fact that we are new we are really the new kid on the block. So it's I would love to be able to even go a bit quicker in replacing more, but we need time. We need time to do the right thing, and not to jump to too quick to conclusions that we can replace everything. So, but yeah, there are things we can do today. The challenge is in working and trying to find what are the other applications we can do tomorrow, the day after.
Yeah, and within the bio-based polymer space, like I think when one looks back to the scaling up of bio-based solutions on an industrial scale, at least that's kind of my perception, that PLA is still like the Ferrari among the new bio-based scalable solutions. Is it still, like, now from an insider like you, would you still see PLA being, the most versatile and the most scaled up in terms of applications and capacity? Or do you also see now new bio-based polymers on the horizon, which could either be competitive or which have also maybe the possibility to scale up in the same way or even better
No,
than
thanks
PLA?
for the question. I was stuck a bit with the Ferrari because I was thinking about, okay, why are you saying that? Is it about the speed of the development? Is it about the fact that it's very expensive, or the fact that actually it's red? So in my head, I was trying to reconnect the image. But now, joke apart, I think you're correct to say that PLA is the one which is, if you think about the volume and the tonnage put out there, is one of the top bioplastics. That is correct. I mean, we have a sizable size, and that's something that coming from the plastic industry, I understand you need size. When you talk to a Procter and Gamble, when you talk to an Unilever, you talk to L'Oreal, you need to bring innovation, but you need also to bring the scale. So that's something that sometimes in the bioplastic industry, and for good reason, at the beginning you focus on an innovation, you focus on a solution, and you focus on the R&D part. But when you really want to propose a solution, especially with the big guys I mentioned, you definitely need size. So on the size, I would tend to agree with you. Yeah, definitely that is one of the few which has dimension, right? Size. Having said that, you say, okay, what is the industry I'm playing in? I'm playing in the plastic industry. I mean, last year it was 400 million tons, right? So I think the total industry of bioplastics, I mean, if you take everything together, I mean, just the PLA by itself, if you want, is around 300,000 tons. Yeah. So you have this type of scale, right? So you have to think about what is the story you want to tell. So in a way, yes, PLA, you could argue that it's one of the biggest and largest, but it's very far from really bringing solutions to the rest. Yeah, the bioplastic altogether, it's 1% of the total market, right? So that is altogether, right? So imagine about that, not only PLA. So that's kind of one part of the answer. The other part of your question was saying, okay, is there anything else? Yes, there is other material developing, and it's good. As I said a bit earlier, when you're thinking about the industry of the plastic, you don't have only one petrochemical-based plastic. You need to have a basket in order to answer different needs. Guess what? In bioplastic, it's exactly the same. We need to have some material which would be able more to replace PE type. And then you have actually the starch-based compound, for example. They are very good at that, replacing some of the PP application. They can do that. You have the PHAs or PHBs that are coming with a very nice value proposition when you think about the compostability. So you have, again, I'm taking two examples, but there is myriads of little guys that are coming up, and we need them, right? So we need all this. We need to create this portfolio in order to be able to compete and replace even quicker some of that. So that is the part that is also very exciting, is to be able to collaborate. And I will never, and that's maybe a bit bizarre coming from this industry, but I'm pretty happy when I'm hearing that there is new PLA capacity in the world, right? I'm pretty happy when I'm hearing that PHA is taking some application that PLA cannot take, right? these are good news.
Yeah,
They are
yeah.
good news for us. I mean, it's a market where just growth is here for everybody, and we should all benefit from each other. So that is also a nice industry to be in from that standpoint. Yeah.
Given that in bio and we've been kind of working in this field for a couple of years now, one thing that I've heard often is bio-based plastics could compete with food. Given that PLA is kind of sourced from sugarcane and diabetics is like on the rise, would you think that's a good thing that you're taking away from the sugar that we otherwise would eat and just have like two birds in one stone? Actually, let eat less sugar, convert it into like bio-based plastics. That's a win-win to me.
Yeah.
Am I missing something here?
No, but we get that question a lot, and there is a bit of
Yeah.
positioning behind that question, just to be very transparent. But then what we try to do as a company, and also as an individual, is to look at the facts. What are we really talking about? I mean, and I will start by an image I'm sharing, because most of the time people, they don't even realize. But where does the paper come from? I mean, we are all used in certain way to not to question some and to question others. And again, that's fine. I'm for the debate. Huh? So then you say,
Yep.
okay, fair enough. You would use basically some material coming from basically a plant that could be used to do something else and to be able to feed people, right? Okay, fair enough. So what you're using basically space, arable land that you could be using. So first question is, are we limited by the arable land? No, not at all. I think there is plenty that we can also refurbish and valorize. That's another level of the answer. And then the last one, or even the last before the last, will be to say, okay, how much do you use for this material today? And even if we are growing in the next 5 years, I mean, I think we have some numbers. It's in our website. It's 0.01% of the total arable land, right? And definitely, even if we grow like hell, I'm saying we're doubling everything, maybe it's gonna get to 0.02%. Okay, so
So
it is an interesting challenge, and that's a challenge we're working on. To be fair, so we're working also on second generation, third generation. We are putting some innovation money in order to say, okay, what if we don't use the sugar from the cane, but maybe the plant, the leftover on the field? We are working on that, but I want also
oh
to
well.
stress the fact that we are a business, so in order to be able to invest in the next generation 2 or 3, we would need to continue to valorize what we have today, to find solution, to learn in order to continue to move. So there are different levels of answer to that question, but honestly, it's a good question to be asking ourselves. But let's also put everything on the table in a positive way.
Yeah, absolutely. I mean, nothing is perfect, right?
Yeah.
I guess it makes sense given the opportunity and given the small amount, like it's 0.01%. You said like that's just a no brainer, right? Like that's not, at least not at this stage, a reason also for it to be a deal breaker at all. Like it's worth really exploring, and especially if you say there's opportunities to really move to the second or third generation of that, then it's a huge potential that I see actually.
Yeah, and I think this is exactly also because it's not the first time that we talk about bio-based solutions on plastic climate future, and many times or oftentimes the critical points are brought up, in terms of, yeah, but bioplastics are just 1% of the total plastic need, and or it's being sourced from food from land that could be used for food and so on. But I think one advantage, or one the most important thing is also to look at the sustainability, the positive sustainability effects of scaling up these solutions. And we used to say always, like, when you look at the challenges of bio-based plastics today, and that they only make 1% of the total market. I mean, when plastics were introduced, they were also making 1% of the steel market, for example. And then with time, with 100 years of research and efficiency improvements at scale also. And I think here we have a chance that we should also point out as crucial that with these solutions we have a carbon sink, we have a material solution that can be used for very diverse applications, as you mentioned in the beginning, and still be sustainable and still be even circular, as you mentioned, the biodegradability. And just pointing out this fact, I stumbled upon a nice, interesting video on YouTube that you have on your website, which says, or you talk about how much CO2 does PLA actually save. So now, from your perspective, why is this also a very important question to ask when it comes to sustainable polymer solutions? And how much does it actually
quiz,
save?
Right? No, it's a number I happen to know by heart because we are super proud of it, and I'm saying that being also honest. That is no joke. I mean, that's why I'm waking up every day. If you wake up every day and you say, you know what, if I can convince somebody to use the PLA, I know that it's going to be 75% less CO2 in the atmosphere starting there, right? So from what we call cradle to gate,
Yes.
I know that compared to a basket of PP, PET, PS, in average, it's going to be 75% of CO2 in the air. So that is really a personal driver. I think it's very much shared with the company. In the company, we know why we are here. And then why is it important? That's correct. I mean, why we would care? I mean, I think we start knowing why we care. We see all this deregulation of the weather. It's becoming even more obvious why we should care. But at the end of the day, it's also a matter of what do we want to do? How do we want to deal with the carbon? And I think that is really the carbon economy, the footprint. How do you want to minimize our action? So with basically the PLA, you have the first this saving that I mentioned. So when I'm producing, I'm a bit less. I'm basically exhausting less CO2 in the atmosphere. But the other piece is what I start describing. There is even some very nice positive end of life for this carbon, which we can regenerate, by the way. And what can we do with it? Okay, we can put it back in the earth, right? And to put it in the compost and in the earth that's gonna be producing maybe the next generation of PLA through the plants. Or we can also recycle it. I think something that actually we are pretty proud to have launched a couple of years ago was the first grade of what we call recycled PLA. And people can say, okay, why you would do that? Same story. I want to make sure that this carbon, even though it's a photogenic carbon or if it's a renewable carbon, I want to keep it in use as long as I can. And why I should not do that is not because I'm a bioplastic, that it's not a good idea to give him another life. So we have been putting basically a commercial offering where we proposed 20-30% of recycled PLA. So basically a PLA which has been done with collected waste PLA, if you want, and we want to give that also a chance. So depending on the application, there are some applications where it makes more sense to get basically a compostability end of life. There are also applications where the recycling end of life would be the best, mechanical or chemical. But this is on top. So basically, you start with a positive impact from cradle to gate. So in the production, 75% less. And then on top, if you have the right application, the right end of life, you can even give it a better positive term. So overall, I think it's a win-win for all of us, and we continue to use as efficiently as possible the carbon, especially the renewable carbon that we put to start with.
And just one question to this one. What are the most important arguments for your clients? Are they mostly interested in the sustainability or circularity aspects, or are there any other arguments that they would be
I think
for PLA?
Sometimes I get that question, okay, who are your customers? What do they want? What do they care? to be honest with you, it starts with us. So when we are in front of that shelf, when you make that move to take any of this product, what do we want? Let's start there. I'm maybe oversimplifying, but this is really the truth. I mean, first of all, you want to take something. It could be an article, it could be a packaging, it could be a product that would work, right? So I think we should also realize that we all like to save the world. We all want to do the right thing, but first you need to have a product or an item which works, right? So the performance is really key. I mean, I've been now 20 years in that in that industry. It's very. I think I've never seen any trade-off compared to a sustainability footprint and something which is not working. Yeah? So I think let's be also honest with each other here. You need to bring the performance. You need to bring something which works, right? First and foremost, and then definitely when you have something which works, which does not impact the brand image of, let's take an end user, yeah, they have also their own pledge, their own challenges. They want to do the right thing for good reason, right? So they would pick up basically solutions which are bringing positive impact to their operation. And that's where the PLA is coming into play, or the bioplastic as a whole is coming to play, or sustainable offering, right? They would basically pick up that one because that's helping them to do the right thing, yeah? To downgrade their footprint. So that could be all. That is definitely an element in the decision. And then the last but not the least, which is the economical trade-off, right? We tend to be still on the premium side. So there are applications also from an economical standpoint that would be validated, some not. But we have more and more those discussions because they don't look only at the pure costs with just the cost of the raw material. No, more and more they're looking at their total footprint, how much basically it would save them, if you want, to be less CO2 hungry. How do they curve that? They take that also into account in the discussion now. So there is this kind of three level of discussion about the performance, obviously the sustainability, but at the end of the day, it's also an economical choice.
Yeah, I think once we start also, considering life cycle costs and CO2 taxation, I think your arguments will be even stronger.
This is a very good point. I think at the end of the day, there is really little things we cannot do if we don't get there, right? I mean, the debate has already started. I think we're going to get more and more of this debate. What is really the price of this carbon, and how do we valorize it? It's not a cheap resource, so we need to make sure we do good use of it. So we're pretty also, I would say, present in many of these debates in the different countries. And as you know, it's quite different, the regions where you are, but everybody is trying to find the best solution to that. I believe it's part also of our job, part of our I would say activities to be present in those debates, being in Europe or in the US or in Asia. I asked all my leadership team members to be actually in the board of the different industry association or different lobby groups in order to be present and share data, share positivity, and also the reassurance that there are solutions. We are not completely doomed to use the same type of things forever.
Yeah, so I would like to kind of hook it onto this because you're saying, what's the price of carbon? How do you valorize it? To what degree, and you kind of hinted on this already, is transparency really key there, and is really a key driver? And what kind of activities do you do when it comes to transparency? Do you use certain frameworks or standards or tools, if at all?
Yes, I think it's yes to all of the above.
Okay.
No, but the first thing, and again, we are very proud of that, is to be super transparent to what we do and what is the impact. And I think we have done with the existing model already our life cycle assessment very early in the process, and we have put it on our website. We put the version we use, we put all the source that we're using. We are super transparent. I think we are also in the middle of reassessing it because we have done a lot of progress in our production process. So we will be able even to to have a lower impact LCA, proven and audited. So that is something that we're doing. So start with be transparent about your impact. We are also very much transparent about all the certification that we have for our product. I mentioned the fact that we are compostable. Okay, we are not saying it. We get somebody else to say it. So we are completely following all the standard, being the STDM in the US, being the EN 13432 here in Europe, or you have other standards in Korea. We are very much proud of it. So we are working and making sure that we got everything certified. There is no question about the fact it's positive and it does what we said it would do. So that's very important. But the last leg is actually being part also of the discussion in the different countries about and be I would say a resource for all this legislative body. And because let's face it, I mean, bioplastic is pretty new. Who knows, how to handle this, how to mimic, how to follow, what are the standards? So we're really proud of being part of these different committees in the different regions, being at regional level, being in the industry level, but we want also to impact that discussion. So definitely we do. We are transparent about our own impacts. We are transparent about all the certifications. And we really want to continue to work on designing the next layer of legislation, which will be even more visible and transparent.
Just one quick question on this specifically. Like I see, you're doing the audits, the third party validation of some of these claims, which is very, very important. Following international standards, being super transparent about the LCA. And at the same time, earlier you were saying it also kind of starts with us, like making the right choices as a consumer. How do you translate that, what you're doing, very much upstream, potentially very technical, to the hands of a consumer who has no idea about all of this stuff?
No, that's a very good point. That's a very good point. And so it's also a realization, including us being in the industry. Sometimes you have this package in your hand and say, what is the right action here? Which bin I should aim at, right? Am I doing the right thing there? And where I should put it? So we're all consumer at the end, and we all have this dilemma, right? So I think the more we can educate the different people through the value chain, it's not only the last consumer, but it could be also. We have been very vocal about the fact that PLA can be sorted in any sorting center across the world. Actually, you can just tap a button on this optical sorting machine, and you would pick up not only PLA from the rest of the plastic, but you could also pick up green PLA from transparent PLA. So the technology is there, right? So do we know that? Yes, because we get into that industry, we know now. So we can answer technically some of the things that we could not before. So you can educate through the value chain, not only the final customer. But going back to your specific question, in the final customers, you need to help as much as you can. And we are pretty vocal about the labeling, right? The labeling needs to be there in order to help the person to do the right thing, and it needs to be true. So it's also part of our position. You need not only to develop those standards, but you need to make sure that there is a right ecosystem with it, the right environment in order to make them applied. And this is also the work of the industry, the work of the society. At the end of the day, this is part of it. But we see progresses. We see progresses, and not only in Europe. Maybe I'm digressing. But I've been in China recently, and you have basically the kids. They are taught at school which bins, and then they go back home and they do the game with their parents, saying, Dad, you know where to put this thing? It's here and not there. So these are really positive examples. I'm trying also to cascade and share, because we can do very little things and they have a huge impact. So we all need to act.
Yeah, I got this vision of, like, in the 90s, in the US, they introduced this nutrition labeling fact, where prior to that, if you bought food, there was nothing on it. Like, there was no fat percentage or calories. No one knew about it. Like, now people know what it means because it's been standardized pretty much internationally. Why are we not doing the same thing for non-food products, right? It starts, as you rightly say, with education and standardization, and then also making sure the data is there. people understand the numbers and is validated and trustworthy.
And to be also transparent, I think technology now is immensely superior to I think 5 years ago, 10 years ago. So we can do basically what we want. We can have as much information as we want. We can read as much information as we want. I think the technology and the tools is not the problem. I mean, we have everything we need. No, we need really to collaborate, design ourselves, to understand what we want to do. But we have everything we need. I think collaboration is really critical here.
Yeah. The keyword of collaboration, I wanted to come back to this because like we said in the beginning, we have this 1% of bio-based plastics and so on, and what are the chances, or what has to be done to actually grow this percentage? And I think that's what I heard now over this conversation already a couple of times. It's also about disseminating the knowledge, but also I think collaboration. And you just mentioned you collaborate with the sorters. You try to be also close to the policymakers. Do you see this as really also crucial to be uptaken by other industries in that sense, or other bioplastic producers and then material innovators in this space? Is this now also picking up due to the sustainability discussion?
Yes, it's a complicated question, but okay, if you step back, okay, let me even two step back. The beauty of the plastic industry is that complexity. So I'm a chemical engineer by training. I've been working a bit in the pharmaceutical industry, and I bump into the plastic industry a bit by chance. I say, okay, let me start that. But then I realized that the plastic industry is much more complex than the pharmaceutical industry. And that is not obvious. Mm-hmm. But when you think about what we need to master, is not only to understand the material, we need to understand the converting process. We need to understand myriads of applications, because plastic could be in different type of applications. So different industry, different trends, different performance. So it's a myriad of different dimensions. So now you say, okay, let's do something quick and easy, and then let's basically replace all these other things which has been developed for maybe 50 years, or even 70 years for some plastic. So it does not work like that, right? So it's complex. So you need really to take all the value chain players, align them, and to deliver a solution which is as performing as the other thing, which has been basically developed for many years. So it is complex, okay? Mm-hmm. But having said that, so what? I mean, we've done it with the other plastics. So why we cannot repeat that, right? But we need to have these ecosystems. And in order to do this right and to accelerate, even to go back to your original question, we need to find those collaborations. And we need to create not only the collaboration through the value chains, so going from the raw material producer to the end users and trying to find a solution together, but around us, you need to have the right environment, ecosystem. So what I mean by that is indeed the legislation needs to be there. I think some incentives, the carbon tax, could be there to help all these discussions. The labeling, the legislation, the agreement between countries about some of the imports, export. You need all of that to be also in place to accelerate. But I think I want to stay with a positive message. Collaboration is happening. We are delivering more and more solutions. I mean, think about it. Last year, we developed the face mask out of PLA. So if you're in the industry, you understand that face mask is not easy to develop. I think that's one of the most technical things you can do with plastic. And we managed to do that through collaboration. So I had one face mask made in the US, one in Europe, and one in Asia. And now you can not only be safe, because that's the main purpose. When you put the PP-based mask, you did not care if it was plastic or not, right? You want it to be safe. And that's one beauty of those solutions. And now on top, you can be safe, and you can also make it with bioplastics, right? So this is possible, but we need to continue to push those and collaborate. Collaboration, for me, is a critical one.
So, what is your favorite PLA product? Where you say like this is my most motivating product concept. That's why I'm in in the field of PLA and bio-based plastics.
Yeah, there was a bit of a cut, so I haven't heard the last question. Can you repeat it? Yeah.
So, what is your most favorite PLA product? Like the one that drives you, like, and you say, okay, this is only possible with PLA, or this is why I'm in this industry because you can make such great products.
Yeah, no, it's a good question. I will answer maybe in two levels. The first one is the one I really love, is the one I'm using every day. It's my coffee mug, actually.
Yeah.
And it is,
Okay. Good.
it seems silly as an example, but it's a true example because this is one which is made out of bioplastic, which can go to the dishwasher. So it's as sustainable as a ceramic mug, right? You
Yeah.
would
That's.
use and reuse and reuse, and it's a carbon, which is
Yeah.
really a photogenic one that is there every day. So and I care about this mug. Huh? I know it's where it's coming from. I know who made it, so it's very important for me. So that's one example, but it's another one, right? I mean, you can do a lot now with PLA that you thought would be not possible before. So that's really what is really driving me. The one I'm really most proud of is really the next one. I mean, what else? Bring me a different challenge. We will try to think about. The one we're trying to break in at the moment is the one I start mentioning is the non-woven industry. We before when we started, nobody thought that we could do non-woven article with PLA. No, we can, right? I mean, we are looking more and more at the 3D printing industry. We are breaking into durable goods. We are also thinking about automotive. So all of that are fields, areas, markets that when you started in the 1990s when PLA came, people were thinking, PLA, yeah, you can do what? Maybe you can do these trash bags, yeah, that's it. So that is really the motto of our industry and the motto of our company. Eh? Let's try to find the next frontier, and they are there. I mean, PLA is again. I'm maybe preaching for my core here, but I'm amazed. I mean, you can really transform PLA in so many manners. I mean, thermoform, extrusion coating, injection molding, film, blown film. I mean, I'm impressed by this guy. I mean, this little guy has power.
No, I'm coming from the sports industry also, and I'm actually a surfer. So what I found super fascinating is that because we were looking into, different concepts to replace glass fiber, and there is actually woven. PLA fibers that you can simply use, with bio-based recyclable epoxies to completely have a bio-based surfboard, which performs also, in marine environment. And then you can just put it back into the compost if you use the other components, right? So this one was pretty fascinating. I have never thought that this exists, but I found it 2 years
And
ago.
we have. I don't know if you have looked up some of our press release, but we have actually collaborated with Y. Yeah, you've seen that one,
Yeah,
yeah?
I've seen that.
And it was an impressive project because at the end of the day, we are using even some performance of the PLA, which is even improving the performance of the surfboard. So let me explain what I'm saying. We are going to put basically the PLA within the core of the surfboard with 3D printed cells. So basically, you get not a full core, right? It's like a bee nest shape, honeycomb,
Honeycomb.
exactly
Yeah.
shape. So it's super light, but still super strong. And then they would put on top some. It could be recycled glass fiber and so on, so make it completely sustainable. And the other piece that I discovered talking because I was on holidays. I'm a surfer as well, so I was not far from them. So I went to see them. So we had a tour, and he explained something that I did not know. is that on top, because it's those honeycomb, if you damage your surfboard, you don't have to
Yeah.
replace the full core. You can just replace the piece which has been damaged. So not only gives a sustainable option, but actually a more performing option to those surfboards. But at the end, I'm still a beginner, so I could not really use the one that they were selling. But I'm jealous. I'm still learning how to use a PLA-based surfboard.
That's going to be the next podcast video we're going to do on the
That's a good
beach
one.
with the
I'm jealous.
surfboards.
So that sounds like a good follow-up.
Yeah. Thanks a lot, Thomas. I think this was amazing insights. We still have one very important question remaining, because this is kind of the tradition of Plastic Climate Future. We have since now 2 years where we have a playlist on Spotify, the Plastic Climate Future playlist, and we always ask our guests to name 1 or 2 songs that either are connected to themselves or maybe to the topic itself, or are simply a good music that should be on the playlist. Do you have something for us?
I can try. So I think there is a relation with the title to what we're doing, and it's basically one of my favorite artists. I went to see him in Montreux not so long ago. So the name of the artist is John Baptiste, and the song I would propose is "I Need You," because as I mentioned, I mean, it's everything is about collaboration. So we need you, and we need everybody to really do the right thing. So I think it should meet all of your requirements, being a good song, a good message, and a great youth artist.
Yeah. And it's from Montreux, it's a very good place to be. I used to live in Lausanne for a couple
you know exactly what I mean.
Exactly. Yeah, perfect. Thanks a lot. I think, as I mentioned, we are super honored to have you here tonight, and we're going to look forward to come back to this conversation on the 2 surfboards out of PLA.
Yes, correct.